Good morning, everyone. Myself, Maria Zamani, your maths teacher. So, today we are going to start with geometry. Okay? Okay. As it comes to geometry, you feel a little bit conscious, like we are going to study a difficult chapter like this. But, my dear children, geometry is not at all difficult. It's something you can see all around us. The shapes which we see around us, it's about geometry, right? So, okay, let's start. So let's start with a triangle. Okay, triangle. Have you seen a triangle? When I say the word triangle, what comes into your mind? Triangle. It means try. When you hear this word try, three comes into your mind, right? Three angles, three sides, three corners, right? Okay. Okay. Now, if I say a word like quad in front of you, have you heard this word? QUA, quad. Yes, of course. You heard this word before also. Like when we were doing, have you done the fractions and we divide the circle into four equal parts and see one part of it? What do we call it? We call it as a quarter. QUA quarter, right? Huh? So quarter, the word QUA stands for 4. Okay. So similarly, for today's topic that we are going to start today, that is about the quadrilaterals. Why what are quadrilaterals? What are quadrilaterals? So as you say the word triangle, the word 3 comes in your mind. And when you say the word quadrilateral, the number 4 will come into your mind, right? So quadrilateral stand for 4. Four-sided figure, a figure which is made up of 4 lines, and it should be a closed figure. It is important. Okay, a simple closed figure which is made up of 4 lines and have 4 corners and 4 angles. That is known as a quadrilateral. Now, let's see here. So, first of all, if I ask you to draw any quadrilateral, how will you draw a quadrilateral? Right? How will you draw a quadrilateral? You will make 4-sided closed figure like this one, this one, this one, as well as these 4 lines we have drawn. So it becomes a quadrilateral. When I made a figure with the 4 lines, which is having 4 corners as well as 4 angles, as you can see, 1, 2, 3, and 4. 4 lines, 4 lines, 4 corners, and 4 angles, right? So this becomes a quadrilateral. Okay, now about this quadrilateral, let's revise a few things about quadrilateral, what we know from the previous things. Okay, suppose this is line, this red line, which I'm just making the blue line on it. See, if you can see, this line is opposite to this line, right? These are known as opposite line. The lines which is in front of it, that is known as opposite. Okay, opposite lines. The lines which are in front of it, that is known as opposite lines, right? Okay, from this, okay, this one, blue one, is opposite to the blue one. Okay, now if I'll make this green one line, this is known as adjacent line. This green one and this green one, this is known as adjacent line. Opposite means in front of it, and the adjacent means the next to it, right? Okay, now we are going to study the types of quadrilaterals. The types of quadrilaterals, how many types of quadrilaterals are there? So let's see the first type of quadrilateral. What I've done in the first one, the same quadrilateral I will make, but I will make a few changes in that. What I will do here, yeah. Now, I will make quadrilateral, but I will make its opposite sides parallel. What I will do, I will make its opposite sides parallel. This side is parallel to this one, all right? And this side will be parallel to this one. Okay, I made this parallel, made them parallel. This sides are parallel. This side is parallel to this one, and this one is parallel to this one, right? So it makes what? A quadrilateral in which opposite sides are parallel. Then it is known as a parallelogram. The same quadrilateral I'm making, but the changes which I'm making, just making its opposite sides parallel. That's it. Then it makes what? It forms a parallelogram. Then it is known as what? Then it is known as a parallelogram. Like parallel lines are there, so it is known as parallelogram. So what happens when I draw this parallelogram? I check the measurement of it. Then what happens here? when I check the measurement of it, I found out that this line is equal to this line. This opposite line becomes equals to this line, and this line is equals to this line when I measured it. Suppose if I've drawn 5 centimeter, it also becomes of 5 centimeter. And if I've drawn this of 2 centimeter, it is also again of 2 centimeter. Then this is known as parallelogram, right? This is known as parallelogram. So what we can say a parallelogram, what if I've asked you, what is a parallelogram? How will you define a parallelogram? So you can say a parallelogram is a quadrilateral in which opposite sides are parallel. Opposite sides are parallel. As well as opposite sides are equal. All right. Okay. So we can say this about a parallelogram, right? What is a parallelogram? A parallelogram is something, a parallelogram is a quadrilateral in which opposite sides are equal and opposite sides are parallel. Now, what I've done, I'm going to do something new here. What I'm going to do, I'm just going to make the same parallelogram again, but a little bit change, a little bit change. And what is that change? Suppose, what is that change? Let me tell you. Suppose here, as you can see here, this angle is any angle. You can see any acute angle. This can be any acute angle. And as you can see, this angle, this can be any obtuse angle. So what I'm going to do, I'm going to make them exact 90 degree, not acute, not obtuse. I'm just going to make them just 90 degree. Okay, just make the legs straight like this. If they're tilted like this, I'm just going to make the legs straight, right? So as you can see here, I have drawn this parallelogram. The same parallelogram I have drawn, but here the angles are what? Angles are each 90 degree. What I've done here, the angles are 90 degree. And what same properties does it show of parallelogram? Yes, opposite sides. As you can see, the opposite side are still parallel. Opposite sides are still parallel, as well as the opposite sides are still equal. This one is equal to this, and this one is equal to this. The only thing new here is the angle, nothing else. What is the new here? There's a new thing here, only the angles are new. That is, I made each angle equals to 90 degree. That's it. Now, what is the name of this type of special type of parallelogram? See, this is a special parallelogram. So we are going to call it as rectangle. We are going to call it as rectangle. Okay, so what all the properties does rectangle show? Let's see. What are the properties that rectangle show? Same as parallelogram. Opposite sides equal. Opposite sides parallel. Same as in parallelogram. Plus one more thing is there, and that is that each angle 90 degree. Okay, that's it. This is the only thing change here. Fine. Okay, now we are going to start. Now, same parallelogram we are going to use. Okay, we are going to use the same parallelogram here only. Okay, so in this parallelogram, what we will do here, we will just make the sides equal. That's it. Same parallelogram I'm going to take, and I'm going to make them like this, like this. Suppose there I have taken, suppose I've taken the, in parallelogram I've taken 5 and 2 sides, but I'm going to make these 5 and 2 sides as 5 centimeter each. Like this is parallel to this one, and this is parallel to this one, right? Opposite sides are also parallel, equal, but all are equal. Each side is of equal length. So we can say this as what? We can say this as a rhombus. This is what is known as rhombus, right? Okay. So what we can say about it, it will say show all the properties of a parallelogram, like opposite sides equal. Of course, opposite sides equal and opposite sides parallel, but I'm not going to write opposite side equal. Instead, I will write all sides are equal. Opposite sides parallel and all sides are equal, right? Okay. Now, let's see here. Now, what we have done from here to here, from here to here, from coming here to here, let me show you. From coming here to here, what we have done, we have made each angle 90 degree, right? We have made each angle 90 degree. Now, we will do the same thing. From coming here to here, we will change each angle to 90 degree of this rhombus. Or what we will do from here to here, what we have done from here to here, we're coming downwards, what we have done coming downwards from here to here, we have made the all the sides equal. We have made all side equal. So similarly, we will do it here also. We'll make all the sides equal of this rhombus, sorry, all the sides equal of this quadrilateral, as well as make all the angles 90 degree from here to here. All right. Okay, let's start doing it. So what it will form, let's see. I made a rectangle here, a rectangle in which all the sides are equal, or I can say a rhombus in which all angles is equal to 90 degree. All angles equals to 90 degree. So we can say what is the word for this? This is known as a square. Okay, what is a square in which opposite sides are parallel. And each side is equal, of course, and each angle is equals to how much? 90 degree. Here rhombus poses any angle. There could be any angle. Here it is an acute angle as well an obtuse angle, but a square have all angles equals to 90 degree. Okay, so what are the properties we can say about square right now? What we can say about square here? Wait a second. Yeah, what we can say about square? So let's see the properties of a square here. All sides equal as well as each angle 90 degree. All right. So these are the properties of a square. Okay, all sides equal. So if I ask you angles in a rectangle, are all the angles can we call rectangle as a parallelogram or not? Yes, of course, rectangle is also a parallelogram. Can we call a rhombus as a parallelogram? Yes, rhombus is also a parallelogram. Can we say square as a parallelogram? Yes, square is also a parallelogram because all three of them poses all the properties of a parallelogram. But you cannot say the parallelogram is a rectangle. All parallelograms are not rectangles. All parallelograms are not rhombus, or parallelograms are not squares. Okay, all right? Sure. Okay. So class, till now we have studied about the basic properties of the quadrilaterals. Now we are going to study about the diagonals. I hope you remember what is diagonals. Okay, so let me start with it. Diagonal. What is a diagonal? Diagonal is a line, is again a line which joins opposite sides of a quadrilateral. Opposite vertices of a quadrilateral. Sorry. Okay, so let me draw one diagonal in this quadrilateral for you here. Here I draw this line. Okay, this is a diagonal, right? This is diagonal here and this is diagonal here. So as we just arrange these lines in a quadrilateral, so what happened? They are also arranged. They also, the diagonals, they are also arranged here. So what happens to the diagonals? Let's see about the diagonals here. Suppose if I make a diagonal of this parallelogram, what will happen? You can see and you can measure experimentally also. If you draw the diagonal of a parallelogram, what will happen itself? It will happen itself. What? That opposite sides, sorry, diagonals, they will bisect each other. They're not equal, they bisect each other. They will bisect each other. Bisect, you, I hope you remember what is bisect. Bisect is dividing a line into two equal parts. Suppose this line is of 8 centimeter, then 4 centimeter will be from here to here and 4 centimeter from here to here, right? Okay. Then it is of 16 centimeter, then 8 centimeter from here to here, and here's 8 centimeter from here to here. Okay. This is known as bisect. Okay. So diagonals, so what we can say about the diagonals of a parallelogram bisect each other. Okay, I'm writing it with the dark colored pen. Diagonals bisect each other, right? Diagonals bisect each other of a parallelogram. Now, from coming here to here, from coming parallelogram to rectangle, what we have done, we have made the angles equal to 90 degree. Now, let's see what happens to the diagonals. When we made the angles 90 degree, then what happens to the diagonals here? Okay, let's see. I made these two diagonals. So let's see what happens to the diagonals. Now, diagonals, obviously, they will bisect each other. Definitely, they will bisect each other because rectangle is also a parallelogram. If diagonal bisect each other, the rectangle is also a parallelogram. That means diagonals will bisect each other, definitely. Okay, so we can say diagonals bisect each other. But one more thing, as we added one thing that we made angles 90 degrees. So what will happen? The diagonals will become equal. Diagonals bisect each other and they will be equal, right? Okay. Okay. Now come to this one quickly. Let's come to this one, rhombus, quickly. As soon as we are doing from coming down, what we are doing, we are making the sides equal. From coming here to here, what we are doing, we are making the sides equal here. From coming here to here, we have made the sides equal. Now what we will do here, now we will draw the diagonals of this one as well as the diagonals of this one. And now what we will see here, from coming parallelogram to rhombus, what will happen to the diagonals? Obviously, diagonals will bisect each other because rhombus is also a parallelogram here. So what we will do, what we can see a new thing here. Obviously, it will bisect each other. This one is equals to this one. But a new thing we will see, they bisect each other here in the center. They will be forming 90 degree. Okay, diagonals bisect each other but at right angles. Diagonals bisect each other at right angles. Okay, sure. Now, let's come to the next one. Square. From coming rhombus to square, what we have done, from coming rhombus to square, we have made the angles 90 degree, right? Now we will do the opposite of it. We have made the angles 90 degree as we have done upper side there. Here, from coming here to here, we have made the angles 90 degree. From here to here, we made the angles 90 degree. So as we made the angles 90 degree, what happened to the diagonals? They become equal, right? So as we come from here to here, the diagonals will become equal. As we make this rhombus as 90 degree, it will become equal. Okay. And as you can see from rectangle, from here rectangle, they will become equal, as well as coming down, they bisect each other at right angles. They will bisect also each other at 90 degree. What we can see here, okay, you can see here that this is a square, and the diagonals, they will bisect each other at 90 degree. They are equal, both of them are equal also, as well as they will bisect each other at right angle. 90 degree also they will form all the properties. From rectangle also it will take, from rhombus also it will take, because all the rectangles on all the rhombus, all the squares are rhombus as well as rectangle. So what we can say, diagonals, about diagonals are equal and bisect each other. All right, sure. So these are the basic 4 types of quadrilaterals. Okay, there are 2 more types of quadrilaterals, that is trapezium and a kite. That I will tell you in brief. Okay, so you have to remember these basic properties. What we have done, we have made a parallelogram into a rectangle by making its angle 90 degree, and a parallelogram to a rhombus by making its sides equal. We have made a rhombus to a square by making its angle 90 degree, and a rectangle into a square by making its sides equal, right? So these are the four main types of quadrilateral: parallelogram, rectangle, rhombus, and square. Okay, let's revise them quickly within 1 minute, what we have done so far. Okay, parallelogram, opposite sides are equal, opposite sides are parallel, and diagonals, they bisect each other. As you can see here in this one, what we can see here in this, as this side is parallel to this side is parallel to this side, and diagonals, they're bisecting each other and nothing else. Okay, because this is just we have started here. Okay, now let's proceed to the next question, next part. Okay, let's see rhombus. Opposite sides are equal, opposite sides are parallel, all sides are equal, and diagonals, they bisect each other, and they are forming, as you can see here, what they are forming the right angle over here, right angle here. A rectangle, what is a rectangle? A rectangle is which is having opposite sides equal, opposite sides parallel, and each angle is equals to 90 degrees. And diagonals, they bisect each other, right? As you can see here, let me show you how the diagonals. But one thing you get confused here, actually you think this forms a 90 degree. No, it will not form a 90 degree here. Okay, because it is a rectangle, these sides are not equal, that's why they will not make 90 degree in the center. Okay, they will not make 90 degree in the center. All right, let's start the next one. Let's see the next one. Okay, let me give you a brief discussion about trapezium. Trapezium is something which is having only one side parallel, that is that this side is parallel to this side will not be parallel to this side. Okay, make sure that once only one pair of suppose side is parallel and this side is non-parallel. Okay, it should be non-parallel, then only it will be known as trapezium. If it would be parallel, the other side will also be parallel, then it becomes a parallelogram. Okay, and if I made these non-parallel sides equal, if I made non-parallel side, don't make this side parallel equal to this. If then again it will become a parallelogram. Make non-parallel sides equal. If you make non-parallel sides equal, then it is known as isosceles trapezium. As we know about isosceles triangle, which is having two opposite sides equal. Similarly, this one. Okay. The last one, that is kite, in which pair of adjacent sides are equal. Adjacent, I told you. Adjacent means the nearby one. Okay, the nearby one. The nearby ones, they are just equal. Pair of adjacent sides are equal. This side is equal to this and this side is equal to this side. Okay. And what about diagonals? They bisect the smaller one. This is the longer one. It is bisecting the smaller one into two equal parts like this. So yes, class, here we finish the types of quadrilaterals. We'll study more about kite and parallelogram in our next class. Thank you very much. See you in next class.